So have you understood everyone? Class A, Class B, Class C, Class D, Class E. Generally, questions will be there in university examination on this part. Have you understood?
Yes, sir.
Okay. So this is how it works. You got the idea. So here I have address space. So this is A, B, C, D, E. So total address space, when you add all these addresses, you will have, you got the idea, mm, you will have this much addresses. So here, in this case, I have taken divided it to 4 bits, 4 bits, 4 bits pass. So prefix. So prefix at MSB always starts with 0, and 7 bits are there as prefix network address, and suffix means these are the host address or connection address. So then class B starts with address 0, total 16 bits will be there, 8 plus 8 total 16 bits, and suffix is 16 bits, right? So 2 raised to power 16, these many connections are there for host. You got the idea. And class C always starts with 110, and class D generally is a multicast address, and here it starts with 1110, and class E address starts with 4 ones, and it is reserved for future use. So far it has not been used. It is total waste only. E this thing. So total 8 bits means 2 to the power 7 means 0 to 127 address. 16 bit means 128 to 191 address. Means this max value. Address values, network addressing. If dotted decimal notation, if it starts between with 180, 128 to 191, it will be always B class address. You got the idea? That means if I have a address like this, assuming that I have a address like 145 dot, you got the idea, 145 dot 10 dot 1 dot 1, something like this. Then if it is 145, so since it is having 145, it is coming under, it is lying between the 128 to 191. So 145 lies between 128 to 191, and hence it is class B address. You got the idea. C class generally 192 to 1 what I meant to say 223. So if the address is 198, you got the idea, 198 point, you got the idea, 110 comma 75 dot, you got the idea, dot 10, something like this. If it is there, then I know that you got the idea, this is dot, this is dot. So 198 means if it is between 192 to 223, it is this. So most of the network addresses, you got the idea, are from this 198. If you see your system IP address, you will find it somewhere in this range, 192 to 223, this base. And D is not applicable. It is generally used for multicasting. So it is not available for you to use. Only these 3 addresses are available for public use. Am I clear over here? And E has not been used so far. So this is what is there. Yeah, fine. So I should remove the pen. Okay. So now basically there was address depletion concept called as address depletion. Depletion means shortfall of address. Shortfall means when required number of network hosts or the connections become more and more. You got the idea, become and more, and address space becomes what I meant to say less and less, in the sense, since every time a host is added, it has to be given a distinct IP address for recognizing it. You got the idea, distinctly. But you can see in India itself, more than, you got the idea, 20,000 or 30,000 mobile phones are being purchased in a day. You got the idea? 30 to 40,000 mobile phones are being purchased in a day across India. Now this figure, that means 30 to 40,000 new IP address are to be added. You can take the scenario across the world. What will be the scenario if in India it is 30 to 40,000? In China, you can assume how many people will be purchasing mobile phones on daily basis. You got the idea? This is the rough estimate I am giving. So as the network hosts, as the time passed by, the number of network hosts started increasing, and the address space started decreasing. I mean to say, I had only 4 byte length, 32-bit IP address, which was falling. What I mean to say, useless. Got there, which was falling useless. So class A address can be allocated to 128 organizations across the world. 128 organizations only, because 7 bits means 2 to the power 7 means 128 organizations. But none of the organizations will have these many connections, because 2 to the power, how much? Out of what I mean to say, 24, 32 bits, you have 8 bits reserved for class A. Means prefix is network address is 8 bits, and remaining what I would say 24 bits are reserved for host address or the connection address. So 2 to the power 24 is these many, what I mean to say, this thing. But none of the, so this, how much does it count? So it is nothing but 16 crore 77 lakhs 7,216 nodes. Roughly, you can say more than 2 billions, around 2 billion addresses it can cover. But population across the world itself is around 17 to 20 billion, 17 to 20 billion. So you can see this address fell short to give individual address to the number of hosts that were increasing. And none of the organization, 128 organizations, cannot be this big to accommodate these many 16 crores systems in their organizations. So generally, most of the addresses in A class were wasted, unused. B class address was designed for mid-size organizations, and that is 16 bits addressing. So 16 bits minus means 2 to the power 4. We have seen how many addresses. So that many organizations, and again 2 to the power 16. Again, mid-size organization, 2 to the power 16 means it won't be that big. That many number of systems will not be there. Class C again had a flaw. You got the idea. So too many flaws were there in this. So class E was almost useless. So this was called address depletion. Fell short. I mean to say, addresses, number of IP addresses fell short of number of systems. So I have given the scenario about only mobile phones. That is 30 to 40,000 mobile phones are being purchased. Now assuming that 10,000 laptops are being purchased every day, you can imagine many people are purchasing the tabs also. So assuming that I'm purchasing 20,000 tabs across the day across India. So, and some people are purchasing PCs, personal computers, got the idea, say around 50,000. So you can see these many addresses are to be created in a single day. So addresses are, IP addresses start falling short. So now how I can increase the address size. So if I want to increase the address size, I have to increase the number of what I mean to say bits into it. You got the idea? So there was, a lot of what I mean to say this thing. So here, that is why the address depletion, to address how now we could overcome this problem of address depletion. So shortfall of addresses. So what happened was they introduced the concept of subnetting and supernetting. So now what happened in subnetting, the class A addresses were divided into several subnets, and each subnet had a larger prefix length than the original network. So because of this, if class A was divided into 4 subnets, Each subnet would have prefix 10. Each subnet would have prefix 10. You got the idea? And then at the same time, if all the address in a network are not used, so subnetting will allow the addresses to be divided amongst again several organizations. But the organizations which were having these main addresses, they were not happy of dividing their addresses. You got the idea? So this was the biggest problem. The only same happened with B class, same happened with C class, and ultimately nobody was happy with this, addressing modes. And the only advantage of classful addressing, despite having so many disadvantages, only advantage was it was very easy to recognize the class of the address. Just by seeing the address, I could recognize. Like if first bit is 0, I know that it is a class A address. If the first two bits are what I meant to say 10, I know that it is what I meant to say class B address. And if the address is 110, I know that it is class C address. You got the idea? And if the address is 1110 starts with 1110, I know that it is class D. And if the address starts with 4 ones, I know that it is class E address. So it was the only advantage that I could easily understand uh, what is the class of address, whether address is belonging to A class address or B class address or C class address. Now, if I am having, for example, if I am having an address of this particular type, assuming that it is say 33, you got the idea, dot 33 dot 118 dot 55, you got the idea, 55, right, dot uh, some 88, something like this. Now which class of address this will belong to? Can anybody tell me which class of address it will be? Anyone?
Class A, sir.
Class
A.
A.
Class A.
How did you say class A? So you see, first 8 bits, if you take this 8, convert this into 8-bit form. You got the idea? So how will you do this 8 bits? So it will be nothing but directly you should not assume, presume, and consume. Am I clear over here? So here, if you take 33, right, put it in bits form. So 33 means this bit should be now. If it is 7 bits, if you take, so here it was very clear. You can see 0 to 127. You got the idea? First byte, if the number is 0 to 127, it will be always class A address. So here, since it is 33, I call it is, you got the idea, class A address directly. Or you can see here how exactly this comes. So you take 33. So how exactly 33 can be represented? 1 should be always there. Then 2 should be there. Then 4. So this is how much? 1 plus 2 plus 4. Then this is 8. How much this? 8 4 12, 12 14, 15. How much is this? Then if I take this much, how much is this? Yes. So this is how much? This is 1 plus 2, it is 3 plus 4, 7 plus 8, 15 plus 16, 31. So how will you represent 33?
1 0 0 0 0 1.
How much it will be?
1 4 zeros and 1
1 followed by 4 zeros.
and last one.
And last 1. So this is 32 plus 1, and before this, so it's only 6, this thing. You got the idea? 6, this thing. So total 8 bits if you take, you can see this first bit is 0. So the first bit is 0 indicates that it is class 0 address. You got the idea? It is class 0 address. So this is, you got the idea? So 33 is this. Have you understood? Now, if I want to have an address like 185, you got the idea? 185, 26, 55, right? 55 and 00. So which class of address it will come? 185.26.55.00.
Class B.
185 means which address? 122 to 191. It is B class address. Have you understood?
Sir.
Okay. So this is how in examination you may be given what I meant to say, a question that identify the addresses. Identify the addresses. So you should be able to identify which class of address it falls into. Right. Some 4 or 5 addresses will be given in university examination. It has been asked, and you have been asked to find which class of address it falls into. Right. Now, next topic, is classless addressing. So we had, rapid growth of internet. We had rapid growth of internet, and with this rapid growth of internet, rapidly number of systems were added. I told you, the scenario, simple scenario of a single country where more than 50,000 to 1 lakh PCs are being purchased, 40,000 to 50,000 mobile phones are being purchased, some 20,000 tabs are being purchased, and several other devices are being purchased, and each device has to be given a separate IP address, has to be given a separate IP address, and that started becoming a big problem. So to address that, what they did was they had to increase the number of IP address. So if you want to increase the number of IP addresses, you got the idea. So format of IP v4 is not sufficient. So IPv4 format, packet format only had to be changed. So instead of what I'm saying 4-bit, now they have increased the size to 6 bits. That version was called IPv6 address. Got the idea. So IPv6 address was there, and this IPv6 address is called classless addressing. So here IPv6 addressing is not divided into class A, class B, class C, class D, class E kind of thing. No class addressing. So it is classless addressing, which will be always there in this thing. So how do I define this thing? So a block can be, so how I can do the addressing. So here variable length of blocks were used for classless addressing. It could be 1 address, 2 address, 4 address, 128 address. So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 32, like that addressing would be there. You got the idea? Total. So this is block 1, block 2, block 3, and so on, block M address space. But here, biggest prefix, in an address has to be, you got the idea, power of 2. So it can be, 1-bit address, or it can be 2-bit address, or it can be 4-bit address, or it can be 8-bit address. Last is 2 raised to power 32-bit address. You got the idea? So here, number of addresses in a block need to be a power 2. So this need to be power 2, this needs to be power 2, this needs to be power 2. This also needs to be power 2, and this needs to be a power 2. That was the only, you got the idea, this thing. So this was called variable length block in classless addressing. Since there was no class, because in IPv4 addressing, 8 bits, first 8 bits were prefix and network address, it was called, and remaining 24 bits were called as the host address. And class P, you got the idea, 16 bits. First 16 bits were called network address. The last 16 bits were called as host address. And class C, we had 24, first 24 bits as network address. The last 8 bits were called as last 8 bits were called as a host address, the kind of scenario. But here there is no no such division. So it is no such division in the sense the prefix can be a block of power of 2. So it can be having four bytes, sorry, 4 bits, 2 to the power 4 bits as prefix, or 2 to the power 8 as a prefix, or 2 to the power 12 as a prefix, and that becomes the prefix part, and the remaining part becomes a suffix. So there was no classless. So huge number of what I would say network addresses. So 6 bytes means 2 to the power 6 bytes is 48, 2 to the power 48 bit positions. That meant 2 to the power 48